In 1941, the British Army introduced a new weapon. The soldiers who received it laughed. It looked like it had been assembled from spare plumbing parts. It cost £2 and 10 shillings, less than a pair of boots. It could be manufactured in a single hour. It had no polished wood, no precision machining, no refinement of any kind. Just a steel tube, a spring, a wire stock, and a magazine that made it look almost accidental. Officers called it an embarrassment. Men on the front called it worse. And then somewhere in occupied France in 1943, a resistance fighter opened a canister that fell from a British aircraft the night before, pulled out that same ugly weapon, and did not laugh at all, because it fired 550 rounds per minute, fit under a coat, and was so simple that his network built their own copies in a basement. By the end of the war, it was in the hands of every resistance movement in occupied Europe. French fighters in Paris, Polish underground soldiers in Warsaw, Jewish resistance fighters in the Ghetto, Norwegian saboteurs in the mountains. The weapon that every professional soldier was embarrassed to carry became the weapon that armed a continent of people who refused to stop fighting. 4 million were built. Nobody was laughing anymore. To understand why the Sten existed at all, you have to go back to the beaches of Dunkirk in May 1940, and what Britain lost there. When the British Expeditionary Force evacuated from Dunkirk, they saved 338,000 men. What they did not save was their equipment. Rifles, machine guns, ammunition, vehicles, nearly all of it abandoned on the beaches or destroyed to prevent capture. Britain had pulled its army home, but the army that came home was stripped of almost everything it needed to fight. The factories were working at full capacity. The American Lend-Lease program was beginning to flow, but the gap between what was needed and what existed was enormous and immediate. Something had to fill it, something cheap, fast to produce, and effective enough to matter. 2 engineers at the Royal Small Arms Factory in Enfield were given the problem. Harold Turpin was a designer with a gift for mechanical simplicity. Reginald Shepherd was his colleague, equally practical, equally unbothered by convention. Together they were told to produce a submachine gun that could be manufactured faster and cheaper than anything currently in production. The weapon they designed in 1941 carried their initials and the name of their factory: Shepherd, Turpin, Enfield, the Sten. What Turpin and Shepherd built was not elegant. It was not supposed to be. Every decision in the Sten's design was driven by a single question: can this be made faster and cheaper? The receiver was a simple steel tube, the barrel screwed directly into it. The bolt was a cylindrical piece of steel with a fixed firing pin. The return spring was identical to springs used in industrial machinery. The trigger mechanism had fewer parts than almost any firearm ever designed for military service. The wire stock folded flat against the receiver so the weapon could be concealed under a coat or in a bag. The magazine fed from the left side rather than underneath, which looked strange and made the weapon awkward to hold for soldiers trained on conventional weapons. The side-mounted magazine became the Sten's most recognizable visual feature and its most criticized one. It also created the weapon's most dangerous flaw. The magazine housing doubled as a forward grip, and soldiers instinctively grabbed it when firing. This put pressure on the magazine itself, which could cause feeding failures. The Army spent considerable effort training soldiers not to hold the weapon by its magazine. Many ignored the instruction. Many paid for it with a jam at the worst possible moment. The Sten could also fire accidentally if dropped or jolted. The open bolt design meant that a sharp impact could sometimes cause the bolt to travel forward and fire a round without the trigger being pulled. There were incidents. There were casualties. The weapon's reputation among professional soldiers was never fully recovered from the stories that circulated about its unreliability. Pause and think about why none of that actually mattered for the people who needed the Sten most. A French resistance fighter operating in occupied Paris in 1943 did not have the option of choosing between the Sten and a better weapon. His options were the Sten or nothing. A Polish underground soldier preparing for the Warsaw Uprising did not have access to a properly equipped armory. He had what the SOE could drop into fields at night and what his network could manufacture in secret workshops. A Jewish fighter in the Warsaw Ghetto in April 1943, preparing to resist the final German liquidation of the remaining population, had weapons that had been smuggled in piece by piece over months. Many of those weapons were Stens. For these people, the Sten's flaws were irrelevant. What mattered was that it fired. What mattered was that it was small enough to hide. What mattered above everything else was that it was so mechanically simple that it could be reproduced by people with basic metalworking skills, a drill press, and materials that could be sourced without attracting attention. Let me put you in that basement for a moment. It is early 1943. You are a member of the Polish Home Army, working in a secret workshop beneath a Warsaw apartment building. On the workbench in front of you are the components of a Sten gun that your network has been manufacturing from stolen steel tubing and machine parts. You did not train as a gunsmith. You trained as a machinist before the war, but the Sten requires nothing beyond what a machinist already knows. The receiver is a tube cut to length. The barrel is threaded at one end. The bolt is turned on a lathe. The spring is sourced from industrial suppliers who ask no questions. You have built 11 of them in the past 3 months. Each one will go to a fighter who has nothing else. The Germans occupying your city have tanks, artillery, and tens of thousands of trained soldiers. You have 11 Sten guns built in a basement. The mathematics are not encouraging, but the mathematics were never the point. The point was that you made a choice, and the Sten was simple enough that your choice could be armed. The Warsaw Uprising of August 1944, the larger Polish uprising, distinct from the Ghetto uprising of 1943, saw Home Army fighters using Sten guns produced in exactly these circumstances, alongside weapons captured from German forces and others dropped by Allied aircraft. The uprising lasted 63 days against overwhelming German force. It was ultimately crushed. But the fact that it happened at all, that a civilian population could organize armed resistance on that scale, owed something real to a weapon simple enough to be built in secret and cheap enough to be produced in quantity. The SOE, Britain's Special Operations Executive responsible for supporting resistance movements across occupied Europe, dropped hundreds of thousands of Stens into France, the Netherlands, Belgium, Denmark, Norway, Yugoslavia, and Greece. The weapon became so associated with resistance operations that in some countries it was known simply as the English gun. In France, entire Maquis units were armed with nothing else. In Norway, saboteurs who destroyed the heavy water facility at Vimork carried Stens. In Yugoslavia, Tito's partisans used them alongside captured German weapons throughout the war. But here is the part most people never hear, and it reveals something about the Sten that changes how you see the weapon entirely. The Sten was copied, not just improvised in basements by resistance fighters working from memory, but formally reverse-engineered and produced in quantity by multiple parties. The Germans, who captured enormous numbers of them, manufactured their own version called the MP 3008 in the final months of the war, issued to Volkssturm militia units defending German cities. The design was so simple that German factories already struggling to maintain production of complex weapons could manufacture it without difficulty. The enemy that had mocked the weapon as typical of British industrial decline was building copies of it to arm their last defenders. In Palestine, Jewish underground organizations produced their own Sten copies in secret workshops before the establishment of Israel. The new Israeli Defense Forces used Sten guns in the 1948 Arab-Israeli War. The weapon appeared in conflicts in Southeast Asia, in Africa, in the Middle East, through the 1950s and into the 1960s. In some parts of the world, Sten copies were still being manufactured decades after the original design had been officially retired. Harold Turpin and Reginald Shepard designed the Sten in 1941 to solve an immediate crisis. They did not design it to be beautiful or prestigious or technically sophisticated. They designed it to be built fast, in quantity, by factories that had never made a firearm before, from materials that were available rather than ideal. They succeeded completely. Over 4 million Stens were produced across multiple marks and variants by the end of the war. The professional soldiers who laughed at it in 1941 were not wrong about its flaws. It was crude, it was unreliable compared to more expensive weapons. It could be dangerous to its own user. Every criticism was accurate. But in the basements of Warsaw, in the forests of France, in the cellars where people with nothing were preparing to fight armies with everything, the Sten was not a compromise. It was the difference between being armed and being helpless. They laughed at the plumber's gun. The people who needed it most never laughed at all.